July 1973, Andrews Air Force Base, Maryland. The Shah of Iran watches from the tarmac as two fighter jets prepare to compete for a multi-billion-dollar contract. The F-15 Eagle, brand new, powerful, revolutionary, and the F-14 Tomcat, equally new, but burdened with a reputation for underpowered engines and mechanical problems. The Eagle performs first, flawless, impressive. The Shah nods approvingly. Then comes the Tomcat. The pilot, Lieutenant Commander Don Evans, has a problem. He's burned through most of his fuel during pre-flight checks. He's got just 2,500 pounds remaining, barely enough to complete the demonstration. 1/8 of the Tomcat's fuel capacity. But this gives him something the Eagle doesn't have: the same thrust-to-weight ratio. Evans pushes both throttles to Zone 5 afterburner, maximum thrust. The F-14's variable sweep wings swing from fully swept to fully forward mid-flight. The jet executes a turn at the absolute limit of its performance envelope. A massive vapor cloud erupts off the wings from the shock wave. The Shah is transfixed. That single demonstration sealed the deal. Iran ordered 80 F-14 Tomcats and 714 Phoenix missiles. $2 billion. Today, nearly 50 years later, Iran is the only nation on Earth still flying the F-14 Tomcat. The United States retired them in 2006. But Iran? Against all odds, through revolution, war, sanctions, and isolation, they've kept these 1970s engineering marvels in the sky. This is the story of the most improbable fighter jet fleet in aviation history. A tale of engineering brilliance, combat dominance, desperate improvisation, and technological resilience that defies every expectation. Is Iran's F-14 fleet an engineering marvel or a disaster waiting to happen? The answer is both. To understand why the F-14 became Iran's obsession, you need to understand what made this aircraft special. The Grumman F-14 Tomcat wasn't just a fighter jet. It was a flying technological revolution designed to solve a problem no other aircraft could: defend an entire carrier battle group from Soviet bomber swarms. The Cold War scenario was terrifying. Soviet Tu-22 backfire bombers, each carrying multiple cruise missiles, would attack American carrier groups in waves. Traditional fighters couldn't engage them early enough. By the time conventional interceptors got close, the bombers would have already launched their missiles. The F-14 solution was radical. See farther, shoot farther, kill more targets simultaneously than any fighter in history. The heart of this capability was the Hughes AN/WG-9 radar system, the most powerful fighter radar ever installed in an aircraft. This system could track up to 24 targets simultaneously and engage 6 of them at once. The radar had a range exceeding 100 miles. In the 1970s, this was science fiction made real. Paired with this radar was the AIM-54 Phoenix missile, a 1,000-pound beast with a range of over 100 miles. No other air-to-air missile came close. The Phoenix could engage targets at altitudes from 50 feet to over 80,000 feet. It could hit bombers before they even knew the F-14 was there. An F-14 could theoretically carry 6 Phoenix missiles simultaneously, though in practice, crews typically loaded 2 Phoenixes, 3 AIM-7 Sparrows, 2 AIM-9 Sidewinders, and kept the M61 Vulcan 20mm cannon loaded. This was a weapons package designed to devastate an entire enemy formation. But the Tomcat's most iconic feature was its variable sweep wings. At low speeds, landing, takeoff, or dogfighting, the wings extended forward to 20 degrees, maximizing lift and maneuverability. At high speeds, they swept back to 68 degrees, reducing drag and allowing the aircraft to exceed Mach 2. The wing sweep adjusted automatically based on speed and G-forces, giving pilots optimal performance across the entire flight envelope. Twin Pratt & Whitney TF30 turbofan engines provided the power, though these engines would later prove to be the Tomcat's Achilles heel, prone to compressor stalls if the pilot wasn't careful. The F-14 required a two-person crew. The pilot flew the aircraft. The RIO, the radar intercept officer, managed the sophisticated weapons systems, radar, and navigation. This division of labor was essential. No single person could effectively operate both the aircraft and its complex weapons suite in combat.
For Iran in the early 1970s, the F-14 was perfect. The Shah's Iran faced a specific threat. Soviet MiG-25 Foxbat reconnaissance aircraft regularly violated Iranian airspace, flying at Mach 3 and 80,000 feet. Iran's existing fighters, F-4 Phantoms and F-5 Tigers, couldn't touch them. The MiG-25s flew too high and too fast. Only the F-14 could intercept a MiG-25. In August 1977, Iranian F-14 crews conducted live fire tests, specifically to send a message to Moscow. They successfully shot down a BQM-34E drone flying at 50,000 feet using a Phoenix missile. The Soviet overflights stopped immediately. But the F-14 offered more than just MiG-25 defense. Iran shared borders with the Soviet Union, Iraq, and unstable neighbors. The country needed to defend enormous airspace, one of the largest territorial defense requirements in the Middle East. The F-14's long-range radar and missiles meant a few aircraft could cover vast areas. Additionally, the Shah had ambitions. He envisioned Iran as the regional superpower, the policeman of the Gulf. Advanced military technology was central to that vision. The F-14 was the most sophisticated fighter jet in the world. Owning it placed Iran in an exclusive club. The deal was struck in 1974. 80 F-14A Tomcats, 714 AIM-54A Phoenix missiles, training for pilots and technicians, spare parts, support infrastructure, and construction of specialized facilities. Total cost? Approximately $2 billion. Massive even by today's standards. Deliveries began in January 1976. By 1978, 79 Tomcats had arrived in Iran. The 80th was retained by the United States as a test aircraft and never delivered. Iranian pilots trained at Naval Air Station Miramar in California, yes, the real Top Gun school, alongside U.S. Navy crews. Iranian technicians learned the intricate systems. Iran built Khatami Air Base near Isfahan, specifically to house the Tomcat fleet. For a brief moment, Iran possessed the second most powerful air force in the region, surpassed only by Israel. Then everything changed. February 1979. The Islamic Revolution succeeds. Shah Mohammad Reza Pahlavi flees into exile. Ayatollah Ruhollah Khomeini returns from France and establishes the Islamic Republic. For the F-14 fleet, this was catastrophic. First, the personnel crisis. Most Iranian F-14 pilots and technicians had trained in the United States. They were associated with the Shah's regime. Many feared for their lives and fled the country. Some of the original F-14 pilots were executed simply for having served the Shah. Others were imprisoned. The knowledge base that kept these sophisticated aircraft flying evaporated almost overnight. Then came the sabotage. American contractors still in Iran and Iranian personnel loyal to the Shah reportedly sabotaged systems before leaving. Phoenix missiles were tampered with. Critical spare parts disappeared. Technical manuals were destroyed. The exact extent of this sabotage remains classified, but Western intelligence confirmed it occurred. The United States imposed immediate sanctions. The arms embargo was total. No spare parts, no technical support, no communication with Grumman, the manufacturer. Hundreds of already ordered Phoenix missiles were never delivered. 400 replacement engines were blocked. Training programs were terminated. By mid-1979, most of Iran's 79 Tomcats sat grounded. The few that could fly had degraded radar systems. Many pilots had fled. Maintenance crews were purged. The most sophisticated fighter fleet outside the United States was dying on the ramp. Western intelligence agencies predicted the F-14 fleet would be completely inoperable within 2 years. They were wrong.
September 22, 1980, Iraq invades Iran. Saddam Hussein believed the revolution had crippled Iran's military. He expected a quick victory. The plan was simple: destroy Iran's air force on the ground, then roll through with armor. The Iranian Air Force, including what remained of the F-14 fleet, had other ideas. Within days of the invasion, Iranian technicians worked frantically to make Tomcats operational. Through cannibalization, stripping parts from damaged aircraft to fix others, they got approximately a dozen F-14s airworthy. On September 7, 1980, an Iranian F-14 scored its first kill, an Iraqi Mi-25 helicopter. What happened next shocked military analysts worldwide. Despite having non-functional radars on many aircraft, despite lacking proper maintenance, despite operating with reduced Phoenix missile stocks, Iranian F-14s achieved what can only be described as air superiority. The tactics were brilliant. Iranian F-14s, even with degraded radars, would be directed by ground controllers toward Iraqi formations. Once close enough, the F-14's powerful AWG-9 radar, even partially functional, could detect enemies far before Iraqi radars detected the Tomcat. The psychological effect was devastating. Iraqi pilots learned quickly, if an F-14 is in the area, abort the mission. The mere presence of a Tomcat on combat air patrol was enough to make Iraqi strike packages turn around. Iranian claims suggest F-14s shot down between 130 to 160 Iraqi aircraft during the 8-year war. Western analysts dispute these numbers. Some estimates put it closer to 50 confirmed kills. The truth is likely somewhere in between, obscured by the fog of war and political manipulation of records. What is undisputed, the F-14 achieved a kill ratio of at least 35-1, possibly much higher. Only 5 Iranian F-14s were lost to enemy action during the entire war, 4 to French-built Dassault Mirage F-1s in ambush scenarios, and 1 to a MiG-21. Major Jalil Zandi became the highest-scoring F-14 ace in history, with 11 confirmed kills. He's still the only F-14 ace who ever existed. No U.S. Navy Tomcat pilot ever achieved 5 aerial victories. Iranian pilots described the F-14's dominance simply. Iraqi pilots would see the radar lock-on warning and immediately run. We didn't even have to fire. The Phoenix missile proved its worth. In one legendary incident in November 1982, an Iranian F-14 fired a single Phoenix at a formation of Iraqi fighters escorting a VIP helicopter. The missile detonated between 3 MiG-21s and MiG-23s flying in close formation. All 3 aircraft disintegrated. The helicopter carrying 2 Iraqi generals barely escaped. Another pilot, on March 21, 1985, reportedly shot down 4 Iraqi aircraft in 2 separate engagements in a single day, all while returning from a 6-hour combat air patrol and running on fumes. But the war took its toll.
By 1984, only 40 F-14s remained operational. By 1986, just 25. Spare parts were gone. Engines were wearing out. Avionics were failing. The fleet was dying through attrition. And yet, they kept flying. How do you keep a fleet of the world's most sophisticated fighter jets flying when the manufacturer won't talk to you, the spare parts pipeline is cut off, and half your trained personnel have fled the country? The answer? You become resourceful to a degree that defies belief. Phase 1. Cannibalization. This was the immediate survival strategy. Iran had 79 F-14s. Not all needed to fly. Aircraft that were too damaged or had critical component failures were designated as donors. Maintenance crews stripped these aircraft down to the frame. Engines, avionics, hydraulic pumps, landing gear, flight controls, anything functional. These parts kept other Tomcats flying. By 1985, Iran publicly flew 25 F-14s in a formation over Tehran to demonstrate operational capability. But behind the scenes, perhaps another 20 aircraft existed only as parts sources. Cannibalization is common in air forces facing shortages, but for Iran, it was taken to an extreme. Some F-14s were reduced to empty shells, every usable component harvested. Phase 2. Reverse engineering. This was where Iranian engineering capability truly shined, or attempted to. Iranian technicians began reverse engineering critical components. This wasn't simple copying. The F-14 systems were extraordinarily complex. The avionics alone included hundreds of circuit boards with components that 1970s Iran couldn't manufacture domestically. But they tried anyway. Reports suggest Iranian engineers successfully reverse-engineered and manufactured hydraulic components, landing gear parts, some avionics boards with reduced capability, structural components, brake systems, tires, always in short supply. The complexity of the TF-30 engines were made nearly impossible to replicate. Iran never successfully manufactured a complete engine, though they did develop repair techniques that extended engine life beyond design specifications. The AWG-9 radar was similarly challenging. The sophisticated components required manufacturing capabilities Iran simply didn't have. They could repair and maintain existing systems, but couldn't build new ones.
Phase 3. The black market. When you can't manufacture it yourself, you buy it illegally. Iran established covert procurement networks across the globe. These networks operated through front companies, intermediaries, and sometimes enemies turned partners. The Iran-Contra affair in the 1980s revealed that the United States itself had secretly sold weapons and parts to Iran, despite the embargo. Israel, surprisingly, also sold F-14 parts to Iran during certain periods. Geopolitics makes strange bedfellows. Parts came through networks in Europe, Southeast Asia, and even sympathetic elements in countries officially hostile to Iran. The markup was astronomical. Components that cost $10,000 legitimately might sell for $100,000 on the black market. By the 1990s and 2000s, U.S. federal agents were regularly busting smuggling rings, attempting to export F-14 parts to Iran. Some operations were sophisticated, using multiple shell companies and routing parts through 3 or 4 countries. Phase 4. Indigenous development. Iran's most impressive achievement was developing its own long-range air-to-air missile when Phoenix stocks ran low. The Fakhur 90 project began in the late 2000s. Iranian engineers took the guidance system from MIM-23 Hawk surface-to-air missiles, which Iran possessed in quantity, and packaged it into an airframe similar to the Phoenix. Pre-production Fakhur 90s were delivered in 2017. A full production order of 100 missiles was placed in 2018, designated AIM-23B. These missiles gave the F-14 renewed long-range strike capability. Additionally, Iran claimed to have upgraded avionics on some F-14s.
integrated domestically produced radar warning receivers, and improved navigation systems. The extent and effectiveness of these upgrades remain disputed, but satellite imagery shows F-14s with modified fairings and antennas, suggesting some level of modernization occurred. Phase 5. Innovative maintenance techniques. Perhaps most impressive was simply keeping the airframes themselves flying. The F-14 was designed for aircraft carrier operations, brutal takeoffs and arrested landings that stressed the airframe to the limit. Iran's Tomcats operated from land bases, which reduced some stresses, but they accumulated flight hours far beyond what Grumman ever intended. Iranian maintenance crews developed techniques to repair structural fatigue, extend component lifespans, and jury-rig systems when proper parts weren't available. Former Iranian Air Force personnel describe welding cracks in engine mounts, fabricating replacement parts from raw stock, and creating workaround solutions for systems that had failed. It wasn't pretty. It certainly wasn't by the book, but it worked. This resilience came with trade-offs. Operational readiness rates were abysmal by Western standards. Estimates suggest that of Iran's remaining F-14 fleet, perhaps 40 to 60% are airworthy at any given time. Compare this to U.S. Navy F-14 squadrons, which maintained 75% readiness. The aircraft themselves operate with degraded capabilities. Radars function at reduced range. Avionics were outdated. The TF-30 engines, always problematic, are even less reliable with improvised maintenance. Pilot training is limited by flight hour restrictions. Can't afford to waste flight time when spare parts are scarce and engines might fail. And yet, the fleet continues. As of 2024, Iran operated an estimated 24 to 30 F-14s in active service, with more in various states of repair. 2 were confirmed destroyed in Israeli airstrikes in June 2024, reducing the fleet further. But here's the remarkable part. Nearly 50 years after delivery, 45 years after the revolution, and 16 years after the U.S. Navy retired its last Tomcat, Iran still flies them. That's not a disaster. That's engineering resilience bordering on the miraculous. Let's evaluate objectively. Is Iran's F-14 fleet a success or failure? First, combat effectiveness. By any standard, the F-14 Tomcats' combat record in Iranian service is extraordinary. Even using the most conservative Western estimates of 50 confirmed kills, the kill ratio is 10 to 1. Iranian claims of 130 to 160 victories push this to 30 to 1 or higher. Compare this to the U.S. Navy F-14 combat record, 5 total kills. 2 Libyan Su-22s in 1981, 2 Libyan MiG-23s in 1989, and 1 Iraqi helicopter in 1991. No U.S. Navy F-14 was ever lost in air-to-air combat. Iran's F-14s saw more combat, scored more kills, and lost more aircraft than American Tomcats ever did. The Iranian experience validated what Grumman designed, a lethal long-range interceptor. The fact that Iranian F-14s achieved this while operating with degraded systems, limited training, and improvised maintenance makes it even more impressive. Tactically, Iranian pilots innovated ways to maximize the F-14's strengths while minimizing weaknesses. They used ground-controlled intercept creatively, exploited the psychological impact of the F-14's reputation, and demonstrated exceptional flying skills in disadvantaged situations. From a pure combat effectiveness standpoint, a marvel.
Now consider the sustainability question. Iran has kept F-14s flying for nearly 50 years despite total manufacturer's support cutoff, international sanctions, limited spare parts, personnel purges, black market dependency, technological isolation. This is unprecedented in modern aviation. No other nation has kept such a sophisticated weapons system operational for so long under such adverse conditions. The Soviet Union couldn't keep Western aircraft flying after sanctions. Iraq's Air Force collapsed when support dried up. But Iran? They not only kept the F-14s flying, they fought a war with them and won air superiority. From an engineering resilience perspective, marvel. But now examine the costs: financial, strategic, and human. Financial. The amount Iran has spent on black market parts, reverse engineering programs, and maintenance innovations likely exceeds the original $2 billion purchase price. The economic inefficiency is staggering. Strategic. Iran has had to dedicate enormous resources, skilled engineers, industrial capacity, procurement networks, to sustaining one aging platform. Those resources could have been used to develop domestic fighter programs, purchase modern aircraft from Russia or China, or modernize other defense sectors. By clinging to the F-14, Iran may have missed opportunities to leapfrog to more modern systems. Human cost. The F-14's complexity has claimed lives. Multiple crashes over the decades, including one in 2012 that killed both crew members and another in 2019, resulted from maintenance issues and aging systems. When parts are improvised and aircraft are pushed beyond design limits, accidents become inevitable. From a cost-benefit analysis, disaster. In 2024-2025, Iran faces reality. The F-14 fleet is dying. Reports from late 2024 indicate Iran has negotiated the purchase of Sukhoi Su-35 Flanker E fighters from Russia. This represents a fundamental shift. Iran is finally moving to replace the Tomcats. Israeli airstrikes in June 2024 destroyed at least 2 Iranian F-14s on the ground. The fleet is vulnerable, aging, and increasingly irrelevant against modern air defenses and fifth-generation fighters like the F-35. Iran has announced plans to develop a domestic heavyweight fighter based on F-14 technology. Whether this materializes remains to be seen. The technological gap between 1970s design and modern requirements is vast. Realistically, the Iranian F-14 fleet has perhaps 5 to 10 years of operational life remaining, if that. And yet, there's something undeniably remarkable about what Iran achieved. Think about it. The United States, the wealthiest nation with the most advanced aerospace industry on Earth, retired the F-14 in 2006. Too expensive to maintain, too complex, outdated. Iran, under sanctions, internationally isolated, with a fraction of America's resources, kept flying them. That's not just engineering, it's determination bordering on obsession. The F-14 Tomcat in Iranian service is both a testament to brilliant design and a cautionary tale about the costs of maintaining technological superiority in isolation. It proved that a well-designed aircraft can survive long beyond its intended lifespan when operated by determined, skilled personnel. It also proved that no amount of ingenuity can completely overcome systematic resource denial and technological obsolescence. When Iran's last F-14 makes its final flight, whether through mechanical failure, combat loss, or retirement ceremony, it will close one of the most unusual chapters in aviation history. No other foreign military platform has served so long under such circumstances. The Iranian F-14 experience offers lessons for military planners worldwide. Lesson 1. Technology transfer has consequences. The United States sold Iran its most advanced F-14, assuming the Shah's regime would remain stable. When it didn't, those weapons ended up in adversarial hands. Today's arms sales could become tomorrow's threats. Lesson 2. Complexity is a vulnerability. The F-14's sophistication made it incredibly capable, but also extraordinarily difficult to maintain. Simpler systems might have been more sustainable. modern weapon systems should balance capability with supportability. Lesson 3. Never underestimate human ingenuity under pressure. Western analysts repeatedly predicted the Iranian F-14 fleet would collapse within years. They were wrong every time. Motivated engineers and pilots can achieve remarkable things with limited resources. Lesson 4. Pride matters in military operations. The F-14 became a symbol of Iranian aerospace capability and national pride. That symbolic value motivated continued investment beyond rational cost-benefit analysis. Never dismiss the psychological and morale dimensions of military hardware. Lesson 5. Original design quality determines longevity. Grumman built the F-14 to survive brutal carrier landings and high-stress operations. That robust design allowed the airframe to endure far beyond its intended lifespan. Good engineering lasts. The highest-scoring F-14 ace in history isn't an American. It's Iranian Major Jalil Zandi with 11 confirmed kills. The longest service life of any F-14 fleet isn't American. It's Iranian, approaching 50 years. The most combat victories by F-14s aren't American. They're Iranian, with over 130 confirmed kills. These facts are uncomfortable for some, but they're facts nonetheless.
So, is Iran's F-14 Tomcat fleet an engineering marvel or a disaster? The answer is, it depends on what you're measuring. As a weapons system in combat, marvel, the F-14 proved itself as one of the most effective interceptors ever built. Iranian pilots and RIOs validated Grumman's design under the most challenging conditions imaginable. As a sustainability achievement, marvel, keeping sophisticated 1970s technology operational for 5 decades without manufacturer support is an engineering triumph. The ingenuity, determination, and skill required deserves recognition. As a strategic investment, disaster. The resources consumed maintaining an obsolete platform could have been better allocated. The opportunity costs are enormous. The fleet's declining relevance makes continued investment questionable. As a case study in arms transfers, disaster. The F-14 sale demonstrated the risks of sophisticated weapons falling into adversarial hands. The Shah's regime collapsed within years of delivery, turning American technology against American interests. As a testament to human determination, marvel. Against every prediction, every obstacle, every setback, Iranian engineers and pilots kept the F-14 flying. That's worth acknowledging, regardless of politics. The Iranian F-14 story matters beyond Iran. It's a reminder that military technology doesn't exist in a vacuum. Political situations change. Allies become adversaries. Today's arms sales become tomorrow's strategic concerns. It's a lesson about the importance of maintenance logistics in weapon system design. Complexity without supportability is a fatal flaw. The F-14's maintenance burden contributed to its retirement in U.S. service, and that same burden has limited Iranian effectiveness. It's proof that original engineering quality matters. Grumman built an aircraft tough enough to survive carrier operations and flexible enough to adapt to land-based operations in hostile environments. That robust design enabled decades of extended service. And it's a demonstration that motivated people with limited resources can accomplish remarkable things. The Iranian F-14 program succeeded not because of abundant resources, but despite their absence. The F-14 Tomcats' days in Iranian service are numbered. Whether through attrition, combat loss, or planned retirement, the fleet will eventually end. When it does, military historians will study the Iranian F-14 experience for decades. It's a unique case study in aerospace engineering, military logistics,
international relations, and human ingenuity. The pilots who flew combat missions in degraded aircraft with improvised parts. The engineers who retro-engineered sophisticated systems with limited tools. The technicians who kept complex machines flying through sheer determination. The strategists who maximized limited resources to achieve air superiority. They all contributed to a story that defies simple categorization as success or failure, marvel or disaster. It's both, and that complexity is what makes it fascinating. In 1973, Lieutenant Commander Don Evans performed a demonstration flight that convinced the Shah of Iran to buy 80 F-14 Tomcats. He never could have imagined that nearly 50 years later, those same aircraft, or their surviving siblings, would still be flying combat patrols over Iran. He couldn't have predicted that the highest-scoring F-14 ace would be Iranian, not American. He wouldn't have foreseen that the longest-serving F-14 fleet in history would operate under an Islamic republic rather than the U.S. Navy. But then, history rarely unfolds as we expect. The F-14 Tomcats' Iranian chapter is ending, but its legacy as both engineering triumph and strategic complexity will endure far longer than the aircraft themselves. That's the real story, not just what was built, but what people did with it when everything went wrong. And, in that sense, Iran's F-14 fleet is the greatest tribute to Grumman's engineering that could ever exist. Not because it was maintained perfectly, not because it was used as intended, but because, against impossible odds, it survived. If this deep dive into one of aviation's most improbable stories opened your eyes to the complexity of military technology and human determination, hit that like button and subscribe. We're bringing you comprehensive investigations into aviation history, engineering marvels, and the human stories behind the machines. Drop a comment. What other aviation mysteries should we investigate? The A-10 Warthog's surprising longevity? The Soviet copy of the B-29? The story of captured enemy aircraft? And if you want to go deeper into aviation engineering and military history, check out the links in the description. Until next time, remember, the measure of great engineering isn't just how well it works when everything goes right, it's how long it survives when everything goes wrong. Keep flying.